great. Today we're going to discuss electrical power system, and I told you guys in my previous class that we are going to have formation of bus admittance matrix. So this is actually the first example formation of bus admittance matrix. So the question says, in the bus transmission system shown below, A, form the bus admittance matrix of the system. B, what are the self-admittances forming the diagonal terms? And we have the bus admittance matrix, and of course it's a 3-bus system. Then it interests me to tell you that whenever you have a 3-bus system, you expect to have a 3x3 matrix. And if a bus transmission system is made of 4 buses, then we talk of 4x4 matrix. That's the matrix that will be formed, will be a 4x4 matrix. So today what we have here is a 3-bus system. We have a bus 1 here, bus 2, and bus 3. Alright, leveling, that's the bus 1, that's the bus 2, and that is the bus 3. Okay, to form the bus admittance matrix, the first thing we do is to write the current of the current equation for current in the first bus, the current in the second bus, and the current in the third bus. So that's the current entering the first bus, I1. The equation for I1 in I1. Of course, before I continue, it interests me to let you know that voltage multiplied by admittance is equal to current. So we're going to use the voltage admittance rule to get the current we are going to use to derive this now. So, I want to prove that current is equal to voltage times admittance. Of course, admittance Y is equal to 1 over impedance. Therefore, the current I is equal to voltage times 1 over impedance. If you can remember this equation, of course, I is equal to voltage over impedance. So you know very well that voltage over impedance is equal to current, because voltage is equal to current times impedance. So this is filtered down to, watered down to V is equal to Iz, which is the voltage equation of the relationship between voltage, current, and impedance. Therefore, any voltage multiplied by impedance is equal to current. So now, we're going to write the equation for current I1 from the first bus, and you find out that the admittance to the ground here is Y10. And of course, then that's the first admittance we're going to write. And of course, V1 is the voltage at bus 1. So we have V1 multiplied by Y10. That's the current at this particular bus. Then if you watch, you find out that the bus 1 is connected to bus 2, and bus 1 is equally connected to bus 3. But let's talk about admittance. The mutual admittance between bus 1 and bus 2 is Y12, and of course the voltage of bus 1 is V1 and the voltage of bus 2 is V2. So this V1 and V2 is involved when it comes to Y12. So the next current here is the current between V1 and V2. That's the current at this particular direction. So we have, of course, the current there is voltage V1 minus V2, and of course that's the voltage because it's between V1 and V2. Then the admittance involved is Y12. Then if you watch again, you find out that V1 is equally connected to, that's bus 1 is equally connected to bus 3, and we are going to have, since of course in this case Bus 1 is our reference bus because we assume that we're moving from bus 1 to 2. So that's why we're having V1 minus V2. The bus 1 is equal to the reference bus, so it has to be V1 minus V3. So here we have V1 minus V3 Y13. So that's the equation 1. Then, of course, I2. Coming to bus 2, the current I2 for bus 2. You can see the admittance to the ground and the voltage V2 multiplied by this admittance to the ground will give us the first current there. So that we have V2 Y20 plus, of course, bus 2 connected to bus 1. In this case, bus 2 becomes the reference because we are in I2. Therefore, in this case, it should be V2 minus V1, then the current involved. It should not be 2, 1, no longer 1, 2, because Y12 and Y21 is exactly the same thing, but in opposite direction. So if I'm addressing bus 2 and we're addressing V2, I2, and in this case, bus 2 is the reference bus, therefore we have V2 connected to V1, and the admittance has to be Y21 now. Y21. Then of course, bus 2 connected to bus 3. In this case, it has to be, of course, V2 minus V3 Y23. That's Y23 is the bus in between. Alright, the equation 3 for I3. Bus 3 is now the reference bus. Bus 3 connected to 1 and bus 3 connected to 2. So first we talk about V3 and the admittance to the ground. We have V3Y30. And of course, bus 3 connected to bus 1, we have V3 minus V1 Y31. Of course, bus 3 connected to bus 2, we have V3 minus V2 Y32. So we have the first equation, the second equation, and the third equation. So these three equations we're seeing here, we can represent it in form of matrix form. That's the form of current equation equal to admittance matrix, current matrix equal to admittance matrix. We write equation in form of current matrix equal to admittance matrix multiplied by voltage matrix. Like we said before, current is equal to admittance multiplied by voltage. So what do I mean? We are going to represent it this way. We're going to represent this way. We have the current matrix, current I1 and I2, and of course I3. I1, I2, I3 is the current matrix here, equal to the admittance matrix. See how we're going to bring down the admittance. If here is the admittance matrix, say the admittance matrix, and of course the voltage V1, V2, and V3. V1, V2, and V3. So the admittance matrix is what we are now going to sort out for. As you can see, V1, V2, V3 are the multipliers. So we are going to find V1 first. So all the admittance that is in line with V1, that's the admittance coefficient of V1, is what we're going to fish out now. So this is the first admittance coefficient of V1, which is Y10. So we are working with V1 now. So all the admittance coefficient of V1 is what we're going to write out here. So the first admittance coefficient of V1 is Y10. We have Y10 plus, then the next admittance coefficient of V1 is Y12. Like trying to open the bracket, you find out that Y12 times 1, that is the next admittance coefficient of V1 is Y12. And the other admittance coefficient is Y13. Okay. We are done with V1. Then V2 to the first equation also. As you can see, the admittance coefficient of V2 here is negative Y12. We have negative Y12. Then the admittance coefficient of V3 is negative Y13. It's negative Y13. So now, for I2, that's equation 2. We look for V1 also, that's the admittance coefficient of V1 is Y20 here. And of course, we have to V1 again here is minus Y minus Y21 minus Y21. As you can see, there is no V1 again. Then we go to V2. The admittance coefficient of V2 is Y21 here. We have Y21 and so V2, and of course here is plus Y23. Then we are done with V2. Then to V3, the admittance coefficient of V3 is just 1. As you can see, Y23 trying to multiply V3, we have negative Y23. That's admittance coefficient of V3. Negative Y23. Okay, to I3 we have, that's equation 3. The admittance coefficient of V1, that's the first thing we're going to talk about as usual, is negative Y31. That's V1, the admittance coefficient is negative Y31. And of course, there is no other place we have V1, so we go to V2. So to V2, we have just one value, that's negative Y32 multiplied by V2. You see negative there. So the admittance coefficient of V2 here is negative Y32. Okay, finally is V3. As you can see, the admittance coefficient of V3 is first is Y30, Y30. Then the next is, of course, is Y31, that's V3 plus Y31 plus lastly is V3 here by admittance coefficient here is Y32. So we've confirmed our equation in the form of current equation equal to current matrix equal to admittance matrix multiplied by voltage matrix. So the equation says form the bus admittance matrix of the system. So now we're going to write the bus admittance matrix. We're going to write the bus admittance matrix, okay? Let's have some space here to be able to write the bus admittance matrix so that we can have Y bus is equal to Y10 plus Y12 plus Y13, comma, minus Y12 minus Y13 again. The next is Y20 minus Y21, comma, Y21 plus Y23 minus Y23. And finally, minus Y31 minus Y32, Y30 plus Y31 plus Y32. So this is my answer. That's the bus admittance matrix of the system. Then the second question says, what are the self-admittances forming the diagonal term? Self-admittances forming the diagonal term. Self-admittance is forming diagonal, then this is A. Question A, the y boss is that thing. Question B, self-admittance is self-admittance forming diagonal, then you know the question already. The self-admittance are y11, y22, and y33. That's because we have 4 bus system. Don't forget, I told you guys that this is going to form a 3 by 3 matrix because of 3 buses. Of course, we have a 3 by 3 matrix here. So y11, the self-admittance forming the diagonal. This is the diagonal. We have the first element in diagonal, the second element in diagonal, and the third element in diagonal as a 3 by 3 square matrix. This diagonal element, the first diagonal element is y11, second diagonal element is y22, the third diagonal element is y33. So definitely y11 is equal to y10 plus y12 plus y13, and y22 is y20 minus and then that's y22 is y21 plus y23, and y33 is y30 plus y31 plus y32. So this is the self-admittance forming the leading diagonal and answer to the second question. Thank you and have a wonderful day. Meet you in my next video. God bless you.